Hello, everyone. I'm Paco Valdez. Welcome. This webinar is called Cut Costs, Not Queries, the case for a universal semantic layer. So I'm a lead solutions architect at Cube. Today, we're going to talk about a challenge that nearly every data team faces, how to manage the growing cost of data while scaling the access to your analytics and AI initiatives. I think the main point of this webinar is about how we can achieve a predictable budget without sacrificing performance. The agenda, we will start with the problem. Let's going to deep dive a little bit into the problem itself. Then we're going to talk about the solution, and then a benchmark that we did just to prove a point. And then we can finish with the takeaways and Q&A. So let's go back to the problem. Basically, when you start to build data products or experiences based on data, the more users you have, the more queries you have, right? So basically, you become a victim of your own success. And the problem is that each of those queries have intrinsic cost. Either you pay it in your data warehouse, your backend application, or if you have a caching layer, in your caching layer. So since you have like multiple types of workloads, you have multiple strategies to accelerate these queries. So it's important to have a unified strategy to accelerate queries, but also to keep your costs predictable and hopefully low. So let's talk a little bit of the solution, and also I will go back and little bit about the problem too. One of the things that happens a lot of times is that there's a caching layer on each step of the way of the pipeline. Sometimes they are in the database itself or data warehouse. Sometimes there's like a middleware that is a caching layer, like in this case will be Cube. But also sometimes the front-end applications have their own caching layer. And each one of them have their own strategies for caching queries. And some of them will be good for some use cases, but for other use cases, they won't perform as good. So the idea is to have a universal semantic layer in between. And yes, there's a caching part on it, which Cube has put a lot of effort on it. But it's also about centralizing how you define your models and where you define the access control for it. For example, you could have a data set that is nicely pre-aggregated in your data warehouse. But once you apply access control rules in your front-end applications, that aggregation won't be as useful as it should. Just because the front-end application is not aggregation aware. If you use Cube or basically a semantic layer with a caching mechanism like Cube does, all your queries from your front-end applications will use your caching in the most efficient way, and also you don't have to worry about access control and the access control affecting your caching strategy. So let's talk also a little bit talk a bit about compute costs. So some of the most of the modern cloud data warehouse measure cost in seconds or minutes or fractions of that. You usually have credits or compute units or slots. Also, you can have multiple concurrent queries, so then you have to think about multiplying these units in the term of concurrency. And then the other problem is that the more complex the query, the more resources they consume. And some data warehouse also bill, or their main bill unit is the amount of data. they have to scan to execute. So that puts a lot of complexity on either the application or your even your data modeling on how to do it in a way that it's cost efficient. So kubectl eliminates that complexity or simplifies it in a way that you define your pre-aggregations in kubectl, and then it will execute the queries at a rate that you are comfortable with to fulfill your SLAs for data freshness. And then you will have cost based on basically just on how much compute you use to calculate those pre-aggregations, and also the compute used to query them, but that's like a smaller fraction of it. We will see later how that works. So basically, you're paying for throughput, not for query complexity or how much data you are scanning. So the way we did this benchmark, we used the TPCH datasets with a scale factor of 100, and the idea was just to build a very realistic example of how like a very complex dataset can be queried in a dashboard or in a embedded analytics application, or even like an ad hoc analysis. So this is a very good example, and just to put like a small preview of what we achieved with this benchmark is that at the scale of 1 million queries per day, we found that kubectl was up to 4 times cheaper and 31 times faster. So let's see how we did that. In Cube, when you define a pre-aggregation, basically the workflow is that you define your data model in Cube, and you don't add any pre-aggregation, like when you start. And then you start to see the query patterns on your Cube application. In kubectl, there's a very good query history page where you can just look at the queries and do some analysis on how long those queries took. So you start with the slowest queries, and then you start basically adding more dimensions or measures to your pre-aggregation. So in this case, I mean, we only have one query, so we just built a pre-aggregation that matches this query. But as you can see, this pre-aggregation has a few dimensions and a few measures. So Cube is pre-aggregate aware. That means that let's assume that here in this pre-aggregation we have total discount. So let's assume with the total discount per market segment. I mean, only those two properties, like the dimension and that measure, you would hit the pre-aggregation regardless, because the idea is that you can slice and dice these pre-aggregations just to retrieve the data that you need for that query. And the other part is that you can also define the granularity of the pre-aggregation, like the time dimension granularity. And then Cube ultimately will roll up to the grain that you need. So for example, well, this example has month, but let's assume I define today, like a date granularity, and then I query by month. It will use the same one because it can roll up, right? Of course, it cannot roll down because you don't have. I mean, you lost the grain when you aggregated it, so you can only roll up. So the idea was to have a very realistic example. So we did some assumptions. So first, we assume that the kubectl production cluster runs 24/7 to keep the pre-aggregations updated. We also know there's some cost for building the pre-aggregations, I mean, in the warehouse, data warehouse, and also in Cube. We also use auto-scaling. So we started with 2 API instances and scaled up to the maximum, which is 10 for a Cube cloud cluster. You can also use multi-cluster in kubecloud. So that has an impact on the on the cost. But I guess for this exercise, we can just extrapolate for the unlimited number of API instances, just to make the formula of calculating the cost easier. The other thing is that the rates that we use. So we use the publicly available price rates for kubecloud and also for data warehouse with no discounts. The other thing was we also try to reach a number of queries per second similar to what we see in production by users from kubecloud. So let me go to this one. So the purple line is the number of queries done in Cube, the Cube, and the blue line is the number of queries in the data warehouse, and then in the y-axis is the cost per query. So as we can see, obviously in there's a fixed cost for building pre-aggregations. So let's assume that we have only one query in a day. So that will be very expensive because we're just basically paying for building the pre-aggregation. In this example, in our benchmark, we have basically two scenarios. One, we go directly to the data warehouse, and the other one, we go to the kubecloud. The other thing to consider is that data warehouses also have their own caching layer. So we try to not hit it, right? We did some random parameters, basically just random date parameters. Just we randomized the second part to make it not hit the cache in the data warehouse. But we did the same in kubecloud, so at least we're comparing the same type of caching strategy on both scenarios. So so the beginning, we can see that it's in kubecloud is more expensive, but then in this example, when we cross the around probably 9,000 queries, we start to see like an inflection on the cost. We cannot see it here, but when we reach 100,000 queries per day, we already were talking about an 89 cost reduction. And by the time we hit 1 million queries per day, we hit 97% on cost reduction. So that's the idea. You have the economy of scale on kubecloud it's really important. The other important part is the speed. So kubecloud with pre-aggregations is very fast because it's in memory multi-layer caching. So you can think about it as a very optimized, maybe like a Trino warehouse, very similar architecture. And the warehouse has to perform other type of operations. But that's why it's a little bit slower in general. So let me see what's the example. So this is the example I was talking about. So at 1 million queries per day, we saw 97.5 cost reduction. Um, so the other part is that one phenomenon that happens in the data warehouse costs is that you can get a volume discount too. So that's also considered in this benchmark. There are things that you can also scale your data warehouse. So your data warehouse, basically the bigger it gets, um, you can process more queries on your data warehouse. That's also considered on the benchmark. So as we grew the number of queries, we also grew the, the size of the data warehouse size. But you can see you cannot even notice the decrease in cost in the blue line. It's basically like a very small um, um, decrease in cost. The biggest decrease in cost happens at the beginning of this chart with respect the blue line. So basically, what this means is that let's assume you are have a dashboard connected directly to your data warehouse. If you have like um, 5 to 10 queries per day, it's actually cheaper to have a bigger warehouse because that will run faster, but will consume less seconds of compute, right? Um, at some point, making this warehouse bigger doesn't help too much. Won't give you as much performance on your queries. What will give you is more concurrency, right? So that's what they are aiming for. But with Cube, we're trying to achieve both things. First, you can achieve high concurrency, and the other thing is that you can achieve low cost. Another thing about the caching strategy in Cube Cloud is that you can define multiple variations for the same type of queries. Let's assume, let me go back a little bit to my definition of my variation. So this one has 6 measures and 5 dimensions. This is like a very specific pattern of queries. But in most real world use cases, your variations probably could be super wide. I mean, you could have like 20 to 50 dimensions or more, or theoretically, I mean, that would be the number of dimensions that you want to accelerate. So one way to do it is to define multiple variations for multiple query patterns. Variations will get evaluated on the order that they are defined. So, for example, if a query doesn't hit or cannot use this variation, then we try to match it with the next one, and so on, until we find like a match. Or if there's no match, then Cube will send that query to the data warehouse. But you define multiple variations for multiple use cases, and also maybe multiple refresh rates. So, for example, for queries that let's think about a dashboard that you have a homepage with like very important KPIs in the first page or in the main dashboard. Think about like just 3 numbers, 3 indicators. That's probably just like 3 different measures and probably 1 dimension or 2. So that could be its own variation that you can update it pretty frequently because it's used a lot. It shows up a lot, but also since it's smaller, you can refresh it pretty often. Then if you have a wider data set that is just when people start to drill down into specifics, that's when you can maybe decide to have that variation that maybe updates not that as fast as the other ones. Um, or if the information that is in there doesn't change that often, right? Maybe like dimensional queries change less often than metrics, right? So you can just define your refresh key um, depending on the use case. The other thing about refresh keys is that it supports not just this cron style of defining increments. You can also put SQL queries. So you can make it even more smart in a way, right? So you can support things like slow changing dimensions. You can check when was the last time dimension was updated. Another use case for that is you could also mm, mm, use, I mean, if you're using an orchestrator, you could define a metadata table where you update that table every time there's a change or a new update on the assets that are updated in that pipeline. So you can you could check that metadata table for the data sets that this pre-aggregation is using. And then the other part of it is that there's another parameter here, partition granularity. So this one is the partition that Cube does is by date. So there's also like a time dimension property with ship date. So this is part of the dimensions that were pre-aggregated, but this one has a specific, has his grain, which is month, but he also has the partition grain, which is how many partitions you can have in a pre-aggregation. Let me see. Let me go forward. See to skip if I skip something important here. Well, I think we could start with some Q&A. One question that I get a lot is how the costs are calculated with QCloud and pre-aggations. So when you deploy a production cluster in Cube, that's 4 CCUs per hour. CCUs is Cube compute units. So similar to other vendors, you have your rate for your unit, for your compute unit, and then you can spend these credits in your account, right? So you have 4 CCUs per unit. Then that's like the baseline of having a production cluster 24/7. The other part is then you have to define your pre-aggregations, right? And then for pre-aggregations, you just pay for the compute used to update those pre-aggregations. So the minimum is 2 workers, 2 cluster workers. So let's assume a pre-aggregation just use 2. So you would pay the fractional time of updating those pre-aggregations. So if those pre-aggregations took, let's say, 10 minutes, you just use the fraction of those 20 minutes of the compute unit to update it. In reality, we're probably like a large data set. You probably will need like 8 to 16 workers. And let's assume that pre-aggregation usually takes between 5 to 10 minutes. That's like a good range. So you would be using 8 workers for 10 minutes. Then the other part is how often you want to bleed it. So let's assume you want to bleed it 1 hour. So it will be that fraction of 1 hour, 1 hour. I mean, 8 workers in 1 hour times 24 hours. So that's a calculation. And then probably you have multiple variations. So that's when one starts to add up. But even at that level, that's still a lot cheaper than just executing your queries um, to the data warehouse. So we have a question: is there any benefits to using pre-aggregations on relatively small databases, but with complicated schema? So yes. So as I mentioned, there's some in real world scenarios, you probably have multiple um, like query patterns, and usually the ones that are the most um, that makes the most sense to aggregate is like when you have this type of like small queries that are repeated a lot, probably just counts of records. Sometimes it's just like one specific metric. So like super ad hoc calculations, that in that case it makes sense to do pre-aggregations, just because it's probably Cube is going to be probably faster than your database. In that case, you probably are paying for speed, not for throughput. And as you know, having fast queries, that's also expensive. So in that case, maybe you're just saving not technically in cost, but in speed. Like having the equivalent fast query in another type of database will be more expensive. Well, I'm checking. Oops, I saw a few more. Okay, so let's talk about there's question is, can you elaborate on the use of indexes? Also, when is preferable to have multiple preargs versus indexes of top of a wide prearg? So indexes in KubeStore, I didn't show it in the definition, and actually I didn't use it in the benchmark because I felt that would be like really cheating, because that would make queries even faster. Indexes are in Cube are in KubeStore, in Cube Cloud, they are not the same as indexes in databases. Indexes in KubeStore are more like subsets of pre-aggregations, that they are just sorted in a different way. When we are talking about like those use cases where they will have 1 million of queries per day, or even more than that, actually querying can be actually very complicated, in the sense that you will need a lot of KubeStore workers just to keep the speeds that you need. Cost-wise, it also affects a bit. But indexes can help to reduce actually cost in Cube by needing less workers for it. So the idea is that if the queries themselves are slow in KubeStore, like if you can notice, let's assume you don't have any query at all in your KubeStore cluster, and then that query itself is slow, then that's when indexes make sense. If the query itself is not that slow, then that's maybe is when it makes sense to have another pre-aggregation. So just to summarize, it comes down to performance. Like if you need performance, that's when you need indexes. If it's more about add more use cases to pre-aggregations, then that's when adding more pre-aggregations is better. We have another question here. I'm curious about the earlier graph comparing cost in data warehouses with and without Cube. It sounds like Cube is really great at cost savings at scale. Is there a way smaller companies should think about using Cube to save money? So the other thing about about the caching layer that with Cube is that Cube has two layers of caching. One is the pre-aggregation store, which is called Cube Store. Another part is the in-memory caching. So the memory caching has its own mechanism, which you can control how often you can invalidate queries. And as you may know, invalidating cache is one of the most difficult problems in engineering. So we have spent a lot of time on that. So actually, even if you don't use pre-aggregations, you can still save a lot just by using this in-memory caching layer. And the other part is that I guess one of the main reasons to use Cube Cloud and as a small company is just it's a lot of cost saving in having humans maintaining or developing a similar type of infrastructure. It's just more just saves a lot of time. It just improves your go-to-market in your application. So, but yeah, I can see a lot of improvements. Maybe not at throughput in queries per second, but in like the other added benefits of having access control, a modeling layer. So yeah, it's about of human time save and infrastructure savings too. There's another one there. Sorry, I was reading in the incorrect order. Cube is positioned as a code-first platform. Can you elaborate on the development workflow? How does version control with Git and implementing CI/CD for semantic model works in practice when promoting changes from a development instance to production? Yeah, so that's a very good question. So Cube Cloud has it's like Git native in a sense that when you go into the data model section, the first thing you notice is that you're in a branch, right? So Cube defines the like a production branch. So you can choose which is your production branch on each deployment. And what happens is that usually, or we recommend to have multiple deployments. For example, you can have a development deployment and then a production deployment, and then the deployment is following a different branch than the production deployment. And then the rest of it is just like the Git workflow, right? So you create a feature branch, and then you can implement CI/CDs there, right? So you can actually run Cube. I mean, you can run Cube in your own CI/CD and run queries against it just to check it didn't break anything on every change. And then when you actually merge to the main branch or your production branch, what Cube does is that it has a blue-green deployment. So it's also Kubernetes based. So it basically just start to create new pods, and then once the pods are healthy, it switches the pods. And the next one is, can KubeCore help with cost without using Cube Cloud? Yeah, so I mean, KubeStore is also in the Cube for Docker image. So basically, you can also deploy KubeStore in your open source deployments. I think the main benefit of kubecloud is just to make that kubecore deployment performant. We have actually have a lot of success on I guess to taking kubecore deployment to the next level. So it's not a bad idea to start with kubecore, and then once you hit infrastructure roadblocks, start considering kubecloud. The next one is how does kube handle subquery complexity, and how does kube handle multi-query nesting? So kube has actually has a subquery. It's actually a dimension type. So subqueries in this dimensional modeling, subqueries are actually dimensions. So basically, when you define a dimension as a subquery type, you usually reference a measure from another cube. So think about you have orders, and then like individual records, and then you want to know from the user that made that order how many other orders that user has. So that will be a subquery, right? You will be a select count from orders where user equals, but that's actually a measure from the user, not from the order itself. So that's how you could define it in Cube using like basically one line that says subtype. Type equals subquery. So it has a lot of complex calculations already implemented out of the box in Cube. And query nesting, multi-query nesting, I guess using the same concept, you could do it multiple times. I mean, you can do a subquery of a subquery. And the other thing is we also have one way is that maybe could be real complex if you go too deep on the nesting. The other way to do it is we have multi-stage type measures. So now instead of thinking about dimensions, if we think about measures, you could do an aggregation, and then on top of that, do another aggregation. And then you can do that multiple times, and there's no limit on that. So that's what the multi-stage means. Basically just like doing map reduce multiple times. And again, those are also just like defining the type of the measure. So there's a lot of out of the box functionality there. One of the use cases for that is like time calculations, like rolling windows, year versus previous year calculations. So that's a lot of things that are already there in Cube. And actually, that's one of the biggest differentiators against other semantic layers. I will leave it like that. That we have been around for so long, and it's been open source that we have had time to solve all those edge cases. Okay, I think I already answered all of them. Well, if there's no more questions, then I think we're good now. Thank you for your time, and please stay check our LinkedIn page. We have a lot of these type of webinars and more. So thank you for your time.